Hello everyone, this is Bao Motion Design, and today we are going to recreate this flower of mine. This is a request from Patreon as a paying member, and I am very grateful for his support. First of all, here are the 3 curves that I created. You can use any other curves. Create a resample node. Convert these curves to polygon. Create a group by range node and select the root of each curve. To fix it in the simulation, create the subdivide node to add more points. Create smooth to make the curve smoother. Create attribute delete node to delete attributes that are not useful. Our curve is set up. Now let's do the vellum simulation and create a vellum hair node. Add some bend strength and increase the thickness. Create a vellum solver node. Gravity is 0 and velocity damping is set to 0.3. Go to the vellum solver node. Create a pop force node to add organic motion. Create a vellum IO node to cache the vellum simulation. Create an attribute copy node to copy the position after the simulation to before the simulation. This eliminates the need to deal with attributes generated by those vellum simulations. Create time shift node. Fixed at the first frame. Create carve node. Truncate half of the curve. Create the phylactic spiral node. This node is from alib and can be downloaded for free from GitHub. With this node, we can quickly create the golden ratio. Create a transform node and shrink it down a bit. Create an attribute VOP node. We want to make a mask that goes from the center to the perimeter. Create a length node. Create a fit range node. We've now got a mask that goes from 0 to 1. Create a ramp parameter node. This node is handy for manual control. Create an up vector. Create a multiply node. Multiply our vector. Create an add node. Add our original position. Output to the position property. Tweak the parameters a bit and now we get a shape like this. These points will be used to duplicate the flower. Create 3 path deform nodes. Deform these points to the curve. Create a sweep node. Generate a round tube. Create array node. Project points onto the round tube. Now just connect the points together to get the branch part. I'll create it via the add node. I need to create an IDD attribute. Points with the same IDD attribute will be connected. Create an orient along curve node. We get the outward N attribute. Create a copy to point node. Copy these spheres to the last point of each curve. Now these spheres are uniform in size. I want them to be variable without creating interspersions. Create a connected adjacent node. It will search for nearby points. Connect them into lines. Output the length of the line. Create an attribute promote node. Promotes rest length minimum as scale. Create attribute copy node to copy to the original points. Now I adjust at will. These balls will automatically resize based on the distance around them. Create sweep nodes to generate the model. Merge them to see that our plant has taken shape. Next, make the flowers. Create a sphere. Create the ofproject node. Create a transform node. Create a matchesize node to align the z-axis. Create a group node and select the bottom of the sphere. I'm going to cut this sphere into even sections. Select the sphere sections to copy the reference node. Sphere connectivity changed to columns. Create a group by range node. Select a few of the lines. Create group promote node. Change the primitive type to point type. Both the group copy node and the group transfer node can be used to pass groups. The difference between them is that one will be based on rules such as point numbers. One is based on distance in space. Here I am using group transfer node. Create a transform node. Scale the passed group a bit. Create an attribute blur node. Smooths the model. Create an edge cusp node cutting the model. The edge cusp node needs the edge group type. So create a group promote node promote point group to edge group. Create an explode view node check if we cut successfully. Next, create the skeleton part. Make a copy of the lines that will be used for cutting. Offset the regularly selected line just to the center of the flower. Create an orient along curve node and output the transform property. Create a rig pose node and check that the matrix properties and hierarchy are correct. It is currently reversed. Create a reverse node to reverse the hierarchy. Create a rig doctor node. Generate the attributes needed for the bones. Capture weights next. Create a bone capture proximity node. Create these weights based on distance. Create a bone deform node. Verify that the weights are correct. Right now these weights are incorrect. Because each petal is too close, we need to isolate each flower and do the capture weights individually. So I create a for each to iterate over each petal. This way each petal will be separated in each iteration. Create an attribute transfer to receive the numbers from your iteration to the skeleton. You can now see that the numbers were created correctly, and the numbers on the bones and flowers correspond. Use vex code to remove the mismatched bones. Now each petal has the correct weights. Next, deal with the animation part. Create a resample node that outputs the curve attribute. This is a mask from 0 to 1. Use the universal growth mask. Use this mask to control the local transform property in kinefx. We get curly bones. Create a bone deform node. Check that the animation is correct. Now it's great. Fuse the bottom half of the flower. Check the animated form of the flower. Create a copy to point node to copy the flower to the branch. I'm now going to use a mask to control the animation. Create a mask from geometry to create a mask. Use Vex code to control the scale attribute scaling with the mask. Create a for each structure. Reference the mask attribute in the attribute VOP POS parameter. The animation range is from 1 to 0.86, so map it with a fit function. Modify the scaling in order to minimize interpolation. Adjust the appearance. The flower animation setup is complete. Moving on to the simulation section. The simulation part is fairly simple. Create a vellum configure softbody node. Adjust the stiffness and fix the bugs. Create a vellum pack node to pack this geometry. Rename the output softbody constraint geometry group. Handle the branching part. Create vellum hair node and adjust hardness. Create vellum pack nodes to pack these geometries. Create vellum unpack these geometries. Create vellum attach geometry nodes to attach to the collision geometry. Generate a model of the trunk part of our first simulation as a collision body. The first vellum attached geometry node handles the relationship between the flower and the collision body. The second vellum attached geometry handles the relationship between the branches and the collision body. The vellum stitch node handles the relationship between the branch and the flower. I use vellum with a usage logic. I first take those constraints on what the objects are as a separate node stream, pack them, then unpack them, and then deal with the relationships between them afterward. Create a vellum reference frame node. This node calculates the velocity of the colliding bodies to give the flower some natural upward motion. Create vellum solver node. Create rest blend node. Import external geometry animations. Control the constraint mesh for the soft part. Keep these flowers some distance away from each other before entering the simulation because they overlap. That will cause vellum to be very slow and produce bad results. Takes about 10 minutes. Post-processing. Create an animated preview. We're done with this setup. Thanks for watching.